Hello everyone, another quick lesson. Finding roots of polynomials. Still we're dealing with trinomials with a leading coefficient 1. Quick vocabulary is root, finding the roots or solutions. Finding the roots means a solution to a polynomial equation, and zeros of a function, a solution to the equation fx equals 0, the x-intercepts of the graph of the function. Before we actually do anything, I want to talk quickly about a zero property rule, or a zero factor property. If two numbers have a product of 0, then at least one of the numbers must be 0. So if AB equals 0, then either A is equal to 0 or B is equal to 0 or both. So let's quickly just use the zero factor property and apply it here. We already have a factor form of this equation or polynomial, so it's just for the purpose of using the zero factor property. So based on the definition where it says that if A, B equals 0, then A equals 0 or B equals 0 or both. So using that, we're going to set up this as x plus 6 equals 0 or x minus 3 equals 0. Therefore, x must be equal negative 6 to satisfy this equation, or x is equal 3. So negative 6 and negative 3 for x would satisfy this given equation and make it equal to 0. Check. So when x is equal to negative 6, we get negative 6 plus 6 times negative 6 minus 3 equals 0. Negative 6 plus 6 gives us 0 times negative 6 minus 3 gives us negative 9 equals to 0. 0 times negative 9 is 0, which is indeed equal to 0. You guys go ahead and check the other one when x is 3. So second example, we can actually really speed up the process when you have these simple factors or trinomials with leading coefficient 1. Right here, you would just pick the x value that is opposite sign of whatever is here in parentheses. So the actual solution or roots of this or zeros of this function would be x equals negative 1 or x equals 5. And you can quickly check if plug in negative 1 here, negative 1 plus 1 gives you 0, or if you plug 5 here, 5 minus 5 gives you 0. So those are the two solutions or zeros of this function. Not always you're going to have equation already written in a factor form. Sometimes you're going to have it in standard or general form. So you have to factor it. These guys are really simple to factor. I usually start with open parentheses and I just fill in. So x times x gives me this x squared. And then I look what are the factors of 12 that can give me 1. On the side you can write down 12. And I know that 4 times 3 gives me 12. How can I get 1 using 4 and 3? Oh, indeed, 4 minus 3. So I use those two numbers and plug it here into parentheses. So I get plus 4, plus because here 4 is positive, and negative 3 because here 3 is negative. And therefore, the solution or the roots of this equation are negative 4 or x is 3. You see how here you have x plus 4, so x must be the opposite because negative 4 plus 4 gives us 0. Same thing here, you have negative 3, so x must be 3 because 3 minus 3 gives you 0. And those are two roots of this equation. Next one, again, because we have a leading coefficient 1, those are really straightforward. And I see that if I have 6, that 1 times 6 would be 6, and getting 7 would be, or negative 7 would be negative 1 plus a negative 6. Or we could just simply say negative 1 minus 6. I see both 1 and 6 must be negative, so I just fill it in. It's going to be x times x, gives us x squared, and we just plug in negative 1 and negative 6. Which one goes first? Doesn't matter. Therefore, x is equal 1 or x is equal 6. So those are roots of this equation. And again, you see, because both of those have the second degree, they're polynomials of second degree, so you get two solutions. In this case, you get two real solutions. Let's do a couple more. Find the roots of the equation. Again, you start opening parentheses. If you had a leading coefficient different than 1, then there's a little bit more involvement, so it's not going to be this straightforward, but it's still not hard. So let's see, x times x. I need 15, so 5 times 3 would give us 15, but I need negative 15, so that means that one of those must be negative. But when I add those two numbers, I'm supposed to get 2, so that means that this one has to be positive, this one has to be negative, because 5 minus 3 gives me 2, and 5 times negative 3 gives me negative 15. So x is equal negative 5, or x is equal 3. Again, those are the two roots of this equation. Okay, the next one. See, once you get hang of it, it's really not difficult. So x times x. So now this one is a little bit tricky because you can do 6 times 1, that can give you 5. But I'm going to write it over here. 6 times 1 are also 3 times 2. We need to get 5. You can get 5 from 6 and 1 by 6 minus 1, or 3 plus 2. However, 6 minus 1 would not work because that means that 1 must be negative, and if you multiply 6 times negative 1, it will give us negative 6, and that would not work because we need positive 6. So this one is not going to work. But 3 and 2 works, because 3 times 2 gives us 6, and positive 3 plus positive 2 gives us 5. Therefore, x is equal negative 3, or x is equal negative 2. So those are two solutions or roots of our equation. Okay? Let's do another exercise. So what I suggest that at this point you pause the video and you try yourself, and when you do that, when you're done, play the video and see if you got it right. If you get stuck, then play the video and see if that can help you move forward. So once again, I open the parentheses, and x times x is x squared, The only way to get 2 is 2 times 1, because 2 is a prime number. And to get 3, it's 2 plus 1. So both of those guys have to be positive. Therefore, the roots of this expression would be -2 or -1. How many zeros does the function have? So, because this is the second degree, see here? It's the second degree, so that we must have up to 2 real solutions. And let's find those solutions. So I'm going to set it equal to 0 because I'm finding the zeros of the function. So once again, you open the double parentheses, set it equal to 0, and then because x times x gives us x squared, you write x here and here. 36, that would be 6 times 6, right? But we see that we need -12x, so -6 and -6 will give us -12. Also, -6 times -6 gives us positive 36. So we see that this is a perfect square trinomial. So x is going to be equal 6. You don't have to repeat it twice. So this one has multiplicity of 6, which is beyond the scope of this course. So as of now, we can just say that solution is x. Basically, it means that this parabola, because this is a parabola, we know that because this is a second degree function, polynomial, goes to the x-axis only at one point, which is this one. Okay, but we'll talk about that in a different video. Once again, what are the zeros of the function? So we have 4x squared minus 12x plus 8 equals to 0. This one is a little different because now we have a leading coefficient that is not 4. So what we do, we multiply 4 times 8. So this 4 times 8 gives us 32. What are the factors of 32 that can give us -12? So obviously 8 times 4 gives us 32, sorry, and -8 minus 4 gives us -12. So what we can do, we can write down 4x squared, and then instead of this middle term, we write -8x minus 4x. We could also write -4x minus, that would probably be better, but that's okay, plus 8 equals 0. So we just factor out what the first two have in common and also the second two in common. So we just group them by first two and the second two terms. And so in the first two have 4x in common. We factor that out. And if you divide 4x squared by 4x, that gives you x. So now you can check 4x times x gives you 4x squared. Same thing you do with -8x divided by 4x gives you -2. Here we can factor out -4. That gives us 4x minus 2 as well equals 0. So now here we can factor out x minus 2. Once you factor that out, what is remaining is 4x and minus 4. So you write down 4x minus 4 equals 0. So from here you set x minus 2 equals 0, or 4x minus 4 equals 0. So you get x is equal to, that's 1, 0 of this function, which means that the graph of this function goes to the x of this point on the x-axis, or x equals 1. So those are two real zeros of this function. So that'll be it for today. If you have any questions, please let me know. Thank you.